Hi guys, just looking at the solution for question 9, exercise 13.8. Y is equal to 2 times the inverse tan of root x. And the first thing we're asked to do is derive our equation. So in this case, we have one x value. We are looking at the chain rule to derive it. So this chain rule states that f prime x is equal to u prime multiplied by v prime u. Okay, so let's just label u and v. So u is our inner function, that's root x, and v is everything else. 2 inverse tan, and written in terms of u, so that's 2 inverse tan u. From here, we derive u and v. So u, root x, is the same as writing x to the power of a half, which means that the derivative is a half times x, all to the power of minus a half. Let's tidy this up. This gives us 1 times x to the minus a half, gives you x to the negative a half, all over 2. Okay, let's keep tidying this. So any negative exponent can be written as a positive exponent on the denominator. So let's bring our x to the minus a half to the bottom. This would give us 1 over 2 times x to the power of a half. We also know that x to the power of a half is the same as writing root x, so that gives us 2 root x. Okay, so we found u prime, and now we have to find v prime in terms of u, so that's the derivative of v in terms of u. So to derive this value, we're going to use page 25 of our log tables to see the derivative of inverse tan of x. The inverse tan of x over a derives to a over a squared plus x squared. So let's use this rule to derive v, which is written in terms of u. Okay, so that's on page 25 of our log tables. Now let's derive. So v prime u is equal to 2 times a over a squared plus x squared. Please note we do not derive the 2 as this is just a multiple that we multiply in at the end. Here we'll substitute in for a and x. So inverse tan of u, that gives us a as 1. So it's 1 all over 1 squared plus u squared. And from here we expand and simplify. This is the same as 2 times 1 over 1. 1 times 1 gives you 1. Plus, instead of writing u, substitute back in what u is. So u was root x, that gives us root x squared. Okay, and from here we're going to multiply our fraction by 2, so that means you're multiplying top by top and bottom by bottom. So it's 2 times 1, which gives you 2, all over 1 plus square root of x squared gives you x. Okay, and from here we found v prime u. So this is our derivative of v written in terms of u. To find the derivative of our function, we multiply u prime by v prime. So we're going to multiply our two derivatives together. So dy dx is equal to u prime multiplied by v prime, which gives us 1 over 2 root x times 2 over 1 plus x. And from here, we're going to multiply our fractions together. That's top by top and bottom by bottom. So 1 times 2 gives us 2 all over 2 root x times 1 plus x. So our derivative of our function f prime x is equal to 2 over 2 root x times 1 plus x. Okay, so that's our answer for part 1. Okay, we find the answer of part 1, so let's look at part 2, which asks us to find the equation of the tangent at 1 pi over 2. So to find the equation of a tangent at 1 pi over 2, we need to find the equation of a straight line. So anytime our formula asks us for the equation of the tangent, the very first thing we do is write down our formula to find the equation of a straight line. This gives us y minus y1 equals m times x minus x1. So to find the equation of a straight line, or the equation of a tangent, you need two things. You need a point on the line, that's x1, y1, and you need the slope of that line, which is m. So we're given a point on the line. We're told that a point on your tangent is 1 pi over 2. And we need to find the slope of our straight line. So remember that the slope of a straight line is the same at every point. So if we find the slope at one point, we'll find the slope of the line. Remember that the derivative of a function gives you the slope. So we want the derivative of our function when x is equal to 1 to find the slope of our line when x is 1. So our derivative of our function is, from part 1, 2 all over 2 root x times 1 plus x. We want the derivative when x is equal to 1, so we substitute in 1 everywhere we see x in our derivative. This gives us f prime of 1 equals 2 over 2 root 1 times 1 plus 1. Okay, let's tidy this up. F prime 1 equals 2 over 2 times root 1 gives you 1 times 1 plus 1, which gives us 2. This is equal to 2 over 4, which simplifies to a half. Our slope equals a half. From here, we have the slope of our tangent. We have a point on our tangent. So to find the equation of the line, we substitute these values into our equation of the tangent. So let's just write that down here. Our point is 1 root 2 and our slope is a half. So our equation of a straight line is y minus y1 equals m times x minus x1. Substituting our values in, this gives us y minus pi over 2 equals 1 over 2 times x minus 1. Okay, let's just now multiply it out and tidy it up. This gives us y minus pi over 2 equals x over 2 minus a half. Okay, and from here we're just going to bring our constant to one side of the equation, which gives us y equals x over 2 minus a half plus pi over 2. Okay, and from here I'm just going to tidy it up a little bit, so I'm going to factorize out our common factor of our constants. So I'm going to factorize out this common factor, which gives us y equals x over 2. Let's factorize out the minus a half, which leaves us with minus a half into minus a half goes once. Minus a half into pi over 2 leaves us with minus pi. Okay, so our final answer is y equals x over 2 minus a half times 1 minus pi.